Okay. Okay. Are we live? We are live. Amazing. So, today, what are we doing today? We are going to be doing some maths, as you can see from the title. Well, I put for the title, I don't know. Too many questions. Anyway, so, the basic idea is, let me go onto the screen view. So the basic idea is we have my handy dandy website called savemyexams.com. Let's expand this, and obviously we have AQA A-level maths, and we're going to be focusing on the pure maths topic questions, and we're going to do it one by one. We're going to do topic, the proof topic, and we're going to do these questions. So, with these questions, my plan is, I'll go back on face view. So, with these questions, my plan is to have the camera right here on my lamp, looking down onto my page, so you can see my page, kind of. I'll zoom in as much as I can, because I have a desk set up as well, you know, being prepared and all. It's 10 o'clock now, and I'm a bit tired, and I might not be able to get too much done. But anyway, beyond the point, we will record this, record my screen, so you can see the question. If you want, you can do the question with me. You can brag how quick you do it than me, and then all of that is going to go into my handy little folder with section 1 being proof. So that's going to go into the pages. Anyway, that's for later. So what are we going to do now? We're going to get this camera. Careful, like nausea alert. I'll have to okay, that's fair. I can get to down. Look at that. So amazing. Now I will go to the desk view, and as you can see quite a bit. It's not massive. We can still get quite a bit out of it. I'll try to write in. Let me see if I can get it any closer down. Issue is that the closer down it is, the more closer it is to my head, annoying me even more. Let's see, technical adjustments. Okay, I think it's gonna have to go like this. I think that's gonna be the best it can be. Okay, so I do like being organized, so let's put this down. And actually, just in case, give me 1 second. Let me have a look. We are live. Let me just listen to myself for a second. Just in case, give me 1 second. Let me have a. Okay, so sound is coming through, so that's amazing. Now we can begin our questions. Just give me a second to prepare this. Preparation is key, as you know. So first question is going to be we're going to do some easy questions first and warm into it. In all honesty, It's 10 o'clock in the night, so I'm not gonna go into the very hard section. So we'll do some easy questions, we'll see how it goes and go from there. So I'm going to be as honest as I can be about these questions, so I'm not going to try to overestimate or underestimate my knowledge. Actually just realised I need to log in. Don't I? Silly me. Let me go on, I guess, for a second and log in. Okay, come on. Where is it? Let's see. Let's see. Okay. So basically I have had some experiments with the functions of, this platform. So basically, where is it? Desk. So basically, we just marked them all right now, but I've given, I think, a few of these, like I think up to the 5th one ago, but obviously I wanted to be more structured, more, outline, more whatnot. So go from the beginning and just, not rush it, basically. Okay, so this is going to be just proof and proof. So let's write that down. That is, let me try to adjust the light. Let me just, so the lights actually come into my eyes. Just a few more technical adjustments. The issue is I could give him a moment. Because if we can have it like this, and I can have it like this, then this is, I guess, better. This is like a one-time thing that I need to do, so bear with me. Okay, so I think this should be good now. Let's put this down, and how do I do this layout? Let's do proof and then proof and then no, so proof and then 1.1 proof. Proof. That's the worst. Can I just remember? I don't like how I wrote that. This is, no. Okay, also, I just realised I'm going to have that whole section. No, because I know what I'm going to do. I'm going to have each, as you can see I have section 1 proof. And inside of this, I have many different folders. I'm going to have the different things in. I'm going to have 1 out of 1 proof in here as well. So I'm not really going to want to label everything because all it will be pre-labeled. So I'll just do question 1. I'm not going to waste too much time. So it's easy questions. questions. Let's get the ruler. Let's get the fancy one. Let's see. Questions. Amazing underlining. Probably won't use the fancy one because actually I can't see where I'm underlining. These are questions. And then question 1. Okay. In a mathematical argument, how are 3 consecutive integers usually denoted algebraically? Okay, so that's easy. You can do that by n. Should I write the question down as well? That is a good question. No, I won't. That's just wasting time. N plus 1 n plus 2. Okay, so let's look at the answer. So consecutive following 1. Let me see how this looks on your guys' screen. This is where the issue may come along, where the answer is actually on that side. The thing is, I'm not going to change. I don't really want to change it that much. Also, I'm not certain if Save My Exam. Well, this is still a free version of Save My Exam, so this isn't actually showing anything that's not supposed to be seen by anyone who hasn't paid the price for it. But still, yeah, no. What I will. Why is it good? Why is it being so difficult? Let me think. What can I do? Technical difficulties again. So if I can put bit here, but then if I put my things there, then that means that the questions can be cut off. And yeah, because of the questions here, they'll usually come up in this corner, cutting the question off, which is more important. Okay, now I won't dabble too much into this. You can look it up yourself, basically, and I'll also go through the answers anyway. So, question 1, and that is consecutive following on, 1 last, starting in the middle, 1 more, so that's just starting in the middle, 1 less, 1 more, and letter can be used and is most common. So, that is all good. Now, because I'm not prepared for anything, let me get a green pen and take it off. Let's see what we have. Nope. Okay. I can probably there's probably some green pen around somewhere, but for now I'll see how green pencil will do. So we have green, orange, and we just need red. Have we got a red? There we have a red. That would be quite good if it did. I didn't have to fiddle about with other things. Oh, yes. You got a red, but that just needs sharpening. Well, I won't sharpen it until I need it. Hopefully I won't need the red, but that is definitely a red. Okay, so we're going to give this a nice green tick, which no one will be able to see, but I know that that's a green tick. Yeah, good enough for now. So we'll mark that as your score is got it. Next question. Question 2. Question 2. In a mathematical argument, how is an even number usually denoted? Similarly, how is an odd number usually denoted? So, this is just easy as well. Let me adjust this so I don't click as much. Okay, so even number is 2n, and odd number is 2n plus 1, because an even times it by 2, you always get an even number. Times it by 2, add 1, you always get an odd number, because an even number plus 1 is always an odd number. But yeah, you can do minus, so not so good. Can I explain that already? Next question. So we're going to give these two ticks. Okay. Question 3. Prove that the sum of two odd numbers is even. So the sum is adding. So I've kind of, in honest, I kind of still remember the concept behind this, so that's why I'll be using similar terminology, but I might as well start using it now, rather than just pretending not to know kind of the basic idea. But there's still many questions I've got to do, so it's not like I'll really be cheating myself by reading the first 3 questions. So let two odd numbers, let n 2n plus 1 and not let two n plus 1 and 2m plus 1 both even, no, odd, no, yes, odd numbers. So if you add, how should I lay this out? So here 2n plus 1 plus 2m plus 1 equals to 2n plus 2m plus 2, which you can turn into 2n plus m plus 1, and because why is this? Because because the sum has a factor of 2. It is even. Just thinking if I do need to make corrections, what color will I make that in? And I think I need to change my game plan a bit, but I think I will do the corrections in blue, because I have blue pens, and I will do the 6 in steel pencils, which is probably not the best idea because it is quite faint, but we'll see. Okay, so let's do on the what numbers be? N plus 2, so n minus 2, and 2m plus minus 1, and where n and p. Now, that e sign, in all honesty, I think that means is always or something, but I know what it means, like those two are, like it's the r in the natural numbers. But the thing is, I'm not certain if I actually have to say that they are natural numbers, because I don't think that's too necessary. But we'll put that in. So let's see what we got. So you add them and then factorize it, finish your statement, since, and so multiple of 2 and therefore is even, because the sum as a factor of 2 is even. So there's 2 marks there. I will give myself 2 marks. So I don't know, let's do some little marking thing over here. 2 out of 2. One out of 1, and then I've demonstrated that these are 2 odd numbers. I've demonstrated that you add them, and demonstrated that you factorize them. I also give an answer. So in my opinion, I don't think the fact that I didn't mention that they're natural numbers makes too much difference. So I'll give myself a tick here. Nope. I'm gonna stop doing them sort of ticks. It's just pointless. It's not like you can even see it, unfortunately. I don't really want to be. No, I'll just use these. So let's give myself a tick here. Tick here. Tick here. Tick there. Tick there. Also, I'm not even sure if anyone's watching, but if you have any clue what the E is, I'll probably find out, or probably remember in a later episode, but right now, I just can't really remember the exact definition. I know the gist, but just don't know what it exactly means. You can let me know. Also, if you want to tell me, no, you need that where N and P are natural numbers, then, and you think that needs to be in there, then do let me know. And should I even do anything with this? In all honesty, I could say we could usually do section better if this and this was stated, but I don't like the answer is so close to how it should be that I don't see the reason why I would need to, you know, improve it much more. Okay. Question 4. Question 4. So, explain why x minus 3 squared for all real values of is greater for all greater than 0 for all real values of x. Okay, so let's see. Explain why . So squared so it's to do with the fact that if you square if you square a number then it will be always positive basically. So if you square a negative number, it will be positive. So to be honest, I'm not certain on the way of explaining this. So I'll leave it as no idea. Yeah. Going to answer. So as stated here, positive times positive equals positive times negative equals positive. Real versus imaginary complex numbers. I don't know what that means. Anyway, all real numbers squared are positive or zero. That's kind of what I said, but I didn't write it down. That's probably, I should have written that down. Okay, let's write that down. Real numbers. And if this was 2 out of 2. Numbers squared are positive or zero. Or zero. X minus 3 is real for all values of x. X minus 3 is for whole real values x. So x squared positive or zero for all real values of x. So x minus 3 squared well be positive positive or zero for all real values of x. X. Okay. That makes sense. That does make sense. So yeah. Okay. I get 0 out of 4. So the basic idea, so I'll have to revisit this at some point. Next question. Prove that the product of two even numbers is a multiple of 4. Okay. So. Question 5. So let's just go with 2n and 2n and 2 times 2n even numbers plus 2 plus n 2n and 2 both even numbers. So 2 product which means times 2 m plus 2 4 and m. If you factorize that is 4 bracket and m, and therefore as 4 is product mod statement is correct. I don't know how to explain it. Right there, there. Yes. But there's a better way of saying that. So let's see. Now two numbers B. 2k and 2m, right? Okay. That's right. Where natural numbers. The high factorial of natural numbers means anything from any positive number basically. So natural numbers they can't be negative. And can it be zero? No, it can't be zero. It can only be positive. Because why can you be negative? If negative, you could not allow them to be negative. I allow them to be anything in all honesty. I don't actually know why it has to be an n. Where it could be everything. See if you have integers, because let's say you have minus 1 times 2 times minus 2, and then you have 3 minus 2 times 3. That is no 3 times 2 that is 6, and then minus 2 minus. That was minus 1, yeah. So that's minus 2 and then 6 times them is minus 12. Still divisible by 4. So actually get why you couldn't have integers or anything. Just real numbers. Always have real numbers, because you can have any number as long as it's there. But but write that down, but I'm intrigued in that's actually the case. So it's multiple of 4. Correct. That is 1 mark here, 1 mark here, 1 mark there, so 2 out of 2. Okay. No. Next question. Here's account error example to show that this is not equal to that. So question 6. So how do we go about it? Well, let me think. So it is. So if you put 2 in there, then if you put 4 in there, then 2 comes out. No, if you put 2 in there, 2 comes out. But if you put minus 2 in there, still 3 comes out. So let x equal to minus 2, and then with that you have minus 2 squared all rooted, which equals to root 4, which equals to 2 and minus 2 are not equal. There we go. Does it? Let's have a look. And next number will work. So yeah, minus 2 and 4 and 2 and yes, that's what I got. Yeah. Yes, mush. It's good. Okay. Next question. How many marks was that? No, that's previous one. Next. Oh, it says in the top right. Go on. Just realize 2 marks. Okay. So 1 mark for this, and 1 mark for this. Question 7. Question 7. Okay. So prove by exhausting all possible factors that 11 is a prime number. Well, to be a prime number, you want to be divided by yourself and 1. But nothing else. Exhausting all possible factors. I don't like to have 11 over 1 close to 11. So 11 is a factor, and then therefore 11 is a factor. then 11 over 2, that would only be 11 over 2. Therefore, not two factor. Free. 11, free. Therefore, free is not factor. But then we'll have to do all these. No. 11 over 4 goes to 11 over 4. Therefore, 4 is there must be an easy way of doing this. Okay, I got this. Let's see. So that's kind of what I've done. It looks like, but 11 is a factor, and 1 is a factor. Those around it. That's no point. And could continue to 11 over 11, but can stop as we have passed 10, which is that. So must have tested all factors. I've heard of this. We can't go about this. So yeah. And what he said. Could continue to always front it down. Two. 11, but can stop as we have passed. But as we passed road. We'll have which is point this 3.31 6 dot. So must have tested all possible factors. So factors. Divisible and one of this must be prime. Okay. So it's 11 is only divisible. So must be prime. So B, yeah. number. Okay, that makes sense. Okay. So that's out of two marks. I'll give myself one mark for I've done this. I did just, but that's like one mark lacking a bit, to be honest. And it's this was two. And this is one out of two. Okay. So let us unsure. Yeah, I was unsure. You kind of had the idea. It's not everything. Next page. I think that's it. I'll finish up. Because it's getting late. We have one page then. The question is, do I carry on on the second page or do I not? Yes, I carry on the second page. Because will it be bothered to... And I don't want to waste that much paper in all honesty. Question it. Wrong pen. Question 8. Square minus Okay. Prove that. Accept free. Okay. So can factorize that. Which turns into k minus minus 3 k minus 3 squared not greater than 0 and register of k minus 3 still greater than 0. I have k is greater than 3. But that's not all you want, do we? Which root? So k can be negative or positive. So that can be minus k minus 3 0 10 to k is greater than minus 3 and as k is greater than 3 and k is minus. Sign should flip, shouldn't it? Because minus k minus k 3 and then k free. Okay, smaller than frame. Therefore, it's just not life frame. I guess maybe. Let's see. Three factorize. Square numbers. Square numbers are always positive. So square is yeah. Okay. Excuse me. Minus 3. It's not equal to 0. Okay, minus 3 is not equal to 0. Equals to 0. Okay, equal to 0. What? Okay, so. So this is true when k minus 3 is not equal to 0. This is true when k minus 3 is equal to 0. Yeah, so those equals 0. Yes. That equals 0. Is that? So 3 is k equals 0. That is always. Yes. It's not equal to 0. That's greater. 0 is not equal to 0. Because it's therefore. And that equals to. That equals to 0. K is equal to 0. So if it's not going to be k, it's not going to be 0. If it's not going to be 3, it's not going to be 0. Kind of, get it. Okay, I'll rewrite that question. So again, I'm factorizing. Give myself. I'll buy the crowd. Labels help. Square numbers are always positive. Square numbers are always positive. 4 0 squared. 4 0 squared. So k minus 3 squared is greater than 0 when k minus 3 is not equal to 0, because if 0 then it won't be greater than 0. And k minus 3 is equal to 0 when k equals 3. Therefore We don't want K to be minus 3. We don't want K to be 0. So K minus squared is greater than 0 when K is not equal to 3. Okay. That is 1 out of 2. I'll give myself self. Unsure. Next one. Show that 0.6 can be written in the form Q, where P and Q are integers. What does this tell you? What type of number 0.6 is? Well, let's try the question first. Question 9. So 0.6 equals to 6 over 10, right? Which equals to 3 over 5. Yep. So guess. Therefore, B equals to 3 Q equals 5. What does this tell me? What the number? Therefore it's quadratic. Let's see. If a number can be written as a quotient, fraction, where numeration and the numerator are integers, the number must be rational. Rational. So this can be written as quotient for P and being integers. So it must be rational. It's also quadratic. At least to my understanding. Okay. Well, I've done now. So I'll go pretty much. But not more. I'll try the whole thing now. Can be written as Just realised. I was of the angle of the camera. Quotient. Fraction. Where number and Yes. The number must be rational. rational, 0.6 be written as a quotient. Quadratic, quadratic. Oh, I think about quotient. We have p and integers. P and B. Integers. So 0.6 must be rational. So 0.6 B quotient. No, I'm pretty sure I'm doing the wrong thing because quadratic is not. I'm spelling it right. Halves. Oh, spell both of them wrong. Quadratic. Yeah, no. I was thinking of the wrong thing. I was thinking of quotient. Quotient. Because which one is it? Quotient. Oh yeah, that's the one I was thinking. Quadrat. No. That's stupidly wrong. No, it's not quotient. It's a quadratic. Yes, because it's quadratic, which means what do you call that? It must be quotient. And quotient is a fraction. But anyway, it's in the integers. So what's the difference between a quotient? What's the difference between them two? Quotient is the result of a division, especially when there can be a remainder as integer and polynomial division. Rational number that can be expressed as the ratio of two integers. Okay. So what types of quotients are there? It's rational. That's it. Quotients. Maths. Function. Why not it give me some times of quotients? That's what I was looking for. Quotient. What if I go back? ratio, fraction, and ratio from can be exactly. Quotient is used for result of dividing into another. It is also used similar or analogous. Quotient. Fractions. Okay, so there's only seems to be one type of quotient, which is rational quotient or rational as is, and yeah, seems to be the thing that's just too rational is fraction or quotient with two integers and integers are just all numbers. So yeah. So I'm assuming you couldn't have 0.45 over 2, so that wouldn't be an integer for the first one. Second one, yes. So yeah, that's alright then. And that seems to have been the last one. So where have we got this? I would not really give myself a mark for that. It's just a bit of maths. So I'll go back on this again. We've done proof 1.1. We've done a little bit of this circle. And let's see. Sorry, I have my paper. I haven't did it as far as this. I don't think so. You can see the majority of both had it in this area. Anyway. So what have we done today? So you can see as well. Question 1, 2, 3, question 4, question 5, 6, 7, and then 8 and 9. So not too much, but still effort still power. So I've talked through quite a bit. Just for myself and possibly for you. But now this one can go into here. And this I'll have to give this another section as in as you can see here, it's a 1.1. So 1.1 seconds of this inside of it has been easy questions. Okay. Good. So one page success. No further. Closer. Anyway. That will do for today. So let's go back to let's see when the test comes. Okay. Always in the way. So I'm trying to cover my head. So basic. I mean, so I can just look at you. So basically, that was good. I like the progress we've done for you. None questions systematically and work them all out. There's things that improve and still things that good at or good enough at. So for the next episode I'll crack on and probably do the medium or move on to improve by contradiction, made level only. So we'll see what we'll go on to for now. I'll leave this 11:33 already, so late. So anyway, if you're enjoying this or want to support me, like, subscribe, whatever you like, and come back for another one, probably soon. So anyway, that's that, and I'll see you next one.